Welcome to the second in our series on 5 random GCSE questions. These are taken from a paper 2 calculator paper, but of course they could easily be done, many of them, without a calculator. So let's look at the first question. So this one is about area and length, scale factor adjustments. So we have these two squares, P and Q. Okay, now the dimensions of P are little p by little p, and this is Q by Q. Okay, so we know that the area of this one is bigger than that one, and it's 21% bigger, which means it's 121% of the area of Q, or the area of Q times 1.21. So I can say that P squared, that's the area of this one, is equal to 1.21 times Q squared. Okay, now if we square root both sides, we get P is 1.1 times Q, because the square root of 121 is 11, and it comes from that. Okay, now the ratio P to Q is therefore, I'll just write it over here. So P to Q is therefore in the ratio 11 to 10, okay, in simplest form. And that's the answer to the first part of that question. Okay, now we've got two circles, and we're told that the circumference of B is 70% of A. So I just put a radius in here like this, and another one in here. Okay, if the circumference is 70%, then so's the radius, because they're both linear measurements, you see. So this one is, I'll just call this R. Okay, and this one is therefore 0.7 times R. Okay, so what we have to do now is just make a connection between the two. So the area of the one on the left is pi times R squared. Okay, and the area of the one on the right, if I write it as a ratio, is pi times 0.7 R, all squared like that, you see. Now you can cancel out the pi's, and you can cancel out the R squareds, and you're left with 1 to 0.7 squared, and 0.7 squared is 0.49. Okay, and when you scale that ratio up to integers, you'll get 100 to 49, and that's the answer. Okay, next question. Okay, in this question we've got to work out the perimeter of this sector. Okay, and we're told what its area is. So we know that the area of a sector comes from a fraction of a circle area. Okay, and the fraction is dependent on the angle in here. So I'm going to call this unknown angle theta. Okay, and we know that if we take theta out of 360, so it's that fraction of a complete circle, which is pi times the radius squared. Okay, and we know that the area is 60 centimeters squared because we're given that in the question. So we can rearrange that to find what the angle theta must be. Okay, so if we do that, we get that theta equals, we've got 60 times 360, okay, and then we're dividing by pi times 8 squared, which is 64 pi. Okay, now you could put that on the calculator and get a numerical value for the angle. Okay, and it would be perfectly okay to do that if you wanted to and give it to a few decimal places, but actually you could just leave it as a simplified fraction, which is 675 over 2 pi. Okay, so that is the angle in degrees of theta. So I'm just going to leave it as 675 over 2 pi. Okay, now to find the perimeter of this shape, okay, I've got two lots of the radius plus the curved piece. Okay, don't forget the two straight pieces as well, because they're part of the perimeter. Okay, so the perimeter, I'm just going to call it P, okay, is going to be made up of two lots of 8 plus the curved piece. Now the curved piece is a fraction of the circumference, which is 2 pi r, and the fraction is the angle, which we now know to be that, okay, so 675 over 2 pi, but then that's going to be over 360, so it's the same as saying 675 over 2 pi times 360, okay, and that's times by 2 times by pi times by the radius. Okay, now again you can see straight away that the 2 pi's will cancel here, so that's very convenient, and this is one of the advantages in leaving it in exact form like this. Okay, so they can actually cancel, and we can simplify the rest of it on the calculator, and it comes to exactly 31 if you put that on the calculator. Okay, so 31 centimeters, and that's the answer. Okay, next question. We have a question here involving a straight line and a perpendicular line that passes through a particular point. Okay, so let's just have a look at how we would approach this problem. Well, if we take the first line, we could rearrange the equation for L. Let's just do that first, and I could write it like this. I could say y equals 5/3 of x plus 6/3, which is the same as 2. Okay, the reason I've done that is in the form y equals mx plus c, right? So the gradient of the line perpendicular to this is negative 3/5. Okay, so we want negative 3/5. So our new line would be of the form y equals negative 3/5 of x plus some constant that we don't yet know. Okay, I'm just going to call it c. Okay, and that's perpendicular. Now we do know that this line has to go through the point 3, negative 7. So we can use that information to find the value of c. So at 3, 7, so at the point with coordinates 3, negative 7, we know that y is negative 7, and that equals negative 3/5 of x, which is 3, plus c. So we can use that information to find what c is. So if I just work on that a little bit, negative 7 equals negative 9/5 plus c. If I add 9/5 to both sides, I get negative 7 plus 9/5 equals c. Okay, and if you put that onto a calculator to save time, that will give you negative 26/5. Okay, so c equals negative 26/5. So the equation of the line that we want is y equals negative 3/5 of x. And now we know what c is, we write it as, well, it's negative 26/5. And that will be your answer. If you want to, you can times everything by 5 and express it like that without any fractions. So you could have 5y equals minus 3x minus 26. Or you could arrange it a different way if you wanted to. But those are all correct answers to that question. Okay, next question. Okay, this is a question involving 3D, a 3D shape and trigonometry in 3 dimensions. Okay, so it's important on questions like this that when you're working on any triangle within the 3D shape, you sketch it out in 2D form. And I'll show you what I mean. So, for example, here we've got to find, we've got this point M. It's not in the middle of DA, but it's on DA such that that ratio is true. Okay, so we're dividing this line of 20 in the ratio 2:3. So I'm going to put M about there. Okay, so M is about there. Dividing that line DA in the ratio 2:3. Well, you can immediately see then that this would be 8 and this would be 12 centimeters. Okay, and I would put that information on quite early on. So what we need to find is the angle. I'll draw it on here so you can see what we're actually looking for. So if you went from M up to this point E, okay, it would make an angle with the base of that shape. Okay, and the best way to illustrate the angle is to kind of show that it would actually be, I'll show you it this way. If you now put a line across the base of the floor like that, okay, I'll just make that a dotted line just to make it a bit clearer what's going on. So if you imagine that line I've just drawn there across the floor of the prism, okay, the angle I'm looking for is this angle in here, like this. Okay, that's the one I'm actually calculating. Now, that comes from the triangle MEB. Okay, but before I can get MEB, I need to know more information. I need to know the length of the line MB and the height BE. Well, let's get the height BE first. So I'm just taking out the triangle on the side of this prism here. Okay, this ABE triangle, and I'm redrawing it in 2 dimensions like this. Okay, we know that this is 25 degrees, and we know that this is 20. Okay, so if I call this little length here x, then I know that x over 20 is the tan of 25 degrees. Okay, so x over 20 is opposite over adjacent, which is the tan of 25. Okay, so therefore the length x is 20 times the tan of 25. Okay, I could find out what that length is by putting it on the calculator, but I don't need to know. I just need to know it's 20 tan 25. Okay, so that's the height here, EB, and I'm going to need that when I come to work out this angle here. Now, I need to know what else, something else about this triangle here, MEB, and I'm going to work out the length across the floor there, okay, from M to B. So if I draw this out in 2D again, here's my right angle. There's one up there as well. So this time, this triangle represents M here, A here, and B. So this is like the triangle on the floor here, drawn upright. And I know that this is 20, and I know that this is 12. Okay, because I've shown that there. And I need to know this length here. Well, if you do 12 squared plus 20 squared, square rooted, okay, I'll just show that here. So 20 squared plus 12 squared. If you square root that and simplify it as a surd, you get 4 root 34. Okay, and again, I wouldn't work out what 4 root 34 is. I would just leave it as 4 root 34. Write it on there. Okay, so I now know something about the length MB. So finally, I can take that length MB, which is 4 root 34, and now look at the triangle that I'm working with, because this is the angle in here that I want. This is M, this is now B, okay, and this is E. We know that this height here is 20 tan 25. And we know that this base here is 4 root 34. So if I call my unknown angle here theta, that's the angle between EM and the base. Okay, so I'm going to call that theta. Then I can say that the tan of theta is this number over this number. Okay, opposite over adjacent. So therefore, theta is the inverse tan of what I just said. So theta is tan to the minus 1, or the inverse tan of opposite over adjacent. So it's 20 tan 25, okay, over 4 root 34. Now, a lot of people would be tempted to be working out these values on the way, and you can do that. There's nothing wrong with doing that. But if you do, make sure you give them to several decimal places of accuracy so that you don't introduce a rounding error. But that's perfectly correct to do it like this. Now, all I need to do is put that in the calculator exactly as it is, okay, and press equals, and it will give me the value of theta, which is 21.7 something, 794. Okay, but you round that to 1 decimal place as requested, so it's 21.8 degrees to 1 dp. Okay, and that's the answer to the question. Quite a tricky one, that. A lot of work to do to get that answer, but there it is. Okay, and the last question. Okay, this is a vector question. This would be a grade 9 question. It's right at the end of the paper, and the first part's quite easy. That was worth 2 marks. This last part's worth 4. Quite a lot of work to do for that. So I'll run through that one with you now. Okay, and this is how it works. Express FE in terms of A. Well, first of all, I'm going to just put this information onto the diagram. So CD equals A. So little a is this vector here. Okay, and DE is the vector B. Okay, and it also tells me that M is the midpoint of DE. So what I'm going to do is I'm just going to put that DE, I'm going to split it in half. So that bit there is a half B. Okay, that's going to be more useful. And this part over here is also a half B. Okay, So they're the two vectors that make up B, going from D to E. And FC is the vector little a minus little b. Okay, so F to C is little a minus little b. Okay, so that vector there is a minus b. So I'm just putting that information onto the diagram. Now it says express FE in terms of A. Well, that's an interesting question, because you're going to start off by having a B in it, but then that will hopefully cancel out. And what this will effectively be telling us is that FE must be parallel to CD if it's only in terms of A. But let's just literally do it as it is. So F to E is equal to, I can do it in 3 stages, you see. I can go F to C, C to D, D to E. Okay, I'll just write it down in full. FC, okay, plus CD plus DE. Okay, and now if I just write each of those in terms of A and B, that will give me, well, FC is A minus B. Okay, now CD is A and DE is B. Okay, and if you combine all those together, you've got A plus A is 2A, and you've got minus B plus B, which is 0, so it's just equal to 2A. Okay, and as you would have expected, there's no B term, because it's telling us that they're basically parallel. Okay, so there's the answer to part A. It's quite straightforward, that part. This part requires a bit more work, and the best approach to this is to find 2 different journeys that connect the points of interest. Now, M is the midpoint of DE. X is the point on FM, such that Fx to Xm is in the ratio n to 1. So Fx to Xm is in the ratio n to 1. And we've got to find what this number n is. Okay. Now, the first thing I'm going to do is I'm going to work out the vector mx. Okay, and I'm going to make 2 separate journeys to mx. So the first journey, I'll highlight it in one color. So let's use that. So let's do mx using this journey. Okay, and that's just simply a fraction of the vector mf. So let's just see what that would be. Right, so I'm going to start by writing that the journey f to m is 2a, okay, 2a, because we worked out that that was 2a. So f to m, okay, this is how I'm going to start. And that's equal to 2a minus a half b. Okay, and what's going to be very useful for us is to reverse that, and therefore to say that the journey m to f is the negative of that. Okay, it's backwards. So what I would do is say that mf is equal to a half b minus 2a. Okay, now we know that mx is some multiple of mf. So mx, which I've highlighted in yellow, okay, is just going to be some multiple. I'm just going to call it lambda. We often use the Greek letters lambda and mu. So some multiple of this, so lambda times a half b minus 2a. Okay, so that's one expression for a journey from m to x going directly. And now I'm going to have a second vector journey from m to x that's going to go from m to d, d to c, and then c to e. Okay, now let me just show you what that will look like. So I'm going from C to E, okay, and it's telling me in the question that x is the point on FM, okay, that is that, but also CXE is a straight line. Now, as you can see, it's not quite looking like a straight line because the diagram isn't drawn to scale, but that doesn't matter. So what I'm going to do is just cheat a little bit here and show a big blob where x is supposed to be there. Okay, so that's the point x, and that's supposed to be a straight line, CXE. Okay, so I can now say that the vector CE, right, I can now express CE as a single vector in terms of A and B, right? So let me just write that down first. So CE is equal to, well, it's going to be little a plus b, okay, because it's a plus a half b plus a half b. So it's simply a plus b, okay. Now, if I wanted to go from m to x, right, I'm now going to take a different route involving CE. So m to x is actually going to be m to d, okay, plus d to c, plus c to x, right? So I'm joining together three vectors to make a single journey from m to x, a different one to what I had before. Okay, now let's put the detail into that. So mx is actually equal to md, which is negative a half b, okay, plus dc, which is negative a. Now it's going to be some multiple, which I'm now going to call mu, of the vector CE. And the vector CE is a plus b. So it's some multiple of the vector a plus b. Okay, so what I've got is two separate expressions for the journey mx. One of them involves lambda and one of them involves mu. And I'm going to be able to form two equations that I solve simultaneously. All right, so what I'm going to do is expand out the brackets from these two equations. So I'll call this one equation 1 and this one equation 2. Okay, now you can see they're both equal to mx. So I can therefore say that from 1 and 2, so I can actually say that 1 equals 2. Okay, because they're both equal to each other, they're both equal to mx. So therefore, lambda, I'm going to expand out the brackets. So a half lambda b minus 2 lambda a must be equal to this equation here. Now, let's put all the b terms together. So I've got minus a half b plus mu b. So I've got mu minus a half, lots of b. Okay. And I've got my a terms. I've got a minus a plus mu a. So I've got mu a minus 1a, which is the same as mu minus 1 times A. Okay, now I've put them in the same order with the B term and then the A term, the B term and then the A term, because you can equate the B coefficients now. So I can say that a half lambda must be equal to mu minus a half. Okay, so a half lambda equals mu minus a half. Okay, and I can also say that minus 2 lambda equals mu minus 1. Okay, so I've got these two unknowns, mu and lambda, and I've got two equations linking them together. Now, there's lots of ways you could solve this. I think what I would do now is I would add a half to both sides of this one to get mu on its own. Okay, so from this one I can say that mu equals, well, it's just going to be a half lambda plus a half. Okay, a half lambda plus a half. And from this one I can add 1 and say that mu equals 1 minus 2 lambda. So because they both equal to mu, I can combine these two equations here and just say that a half lambda plus a half equals 1 minus 2 lambda. All right, so it's quite a lot of work to do on these questions, as you can see. A half lambda plus a half equals 1 minus 2 lambda. Okay, now if you add 2 lambda to both sides, you get 5 over 2 lambda. Okay, 5 over 2 lambda equals a half. Yes, because I need to take a half from both sides, so it'll be a half left here, and therefore 5 lambda equals 1. Okay, just multiplying both sides by 2, and if 5 lambda equals 1, then lambda equals 1/5. Okay, so what that's telling me is that my yellow line here is 1/5 of the total length MF. So MX is, let me just try and write it down here, MX, the length MX, I don't need a vector arrow now, is equal to 1/5 of MF. So that should be 1/5 of MF. So therefore the ratio is 1 to 4. Okay, so that's like the 1 and that's the 4 as a ratio. I'll just put those numbers in brackets because they just represent a ratio. But the ratio given was the other way around. It was from F to M, so it's 4 to 1. Okay, so N equals 4. And that's the answer. Now, there are other ways you could work that out. None of them would be any easier than what we've just done. So it's a grade 9 question, a lot of work involved. Okay, hope that was helpful. Take care.